Have you ever wondered how we discovered the distant and enigmatic world of Pluto? The story begins in the early 20th century with an astronomer named Clyde Tombaugh. In 1930, Tombaugh, working at the Lowell Observatory in Arizona, made a startling discovery. By meticulously comparing photographic plates, he spotted a tiny speck of light moving against the backdrop of fixed stars. This speck of light turned out to be Pluto, a new planet at the very edge of our solar system. At least, that's what we thought at the time. You see, when Pluto was discovered, it was initially classified as the 9th planet in our solar system, joining the ranks of its larger neighbors like Jupiter, Saturn, and Neptune. Yet, as we learned more about the outer reaches of our solar system, our understanding of what constitutes a planet began to evolve. In 2006, the International Astronomical Union, the body that governs the classification of celestial bodies, made a controversial decision. They redefined the term planet, and under this new definition, Pluto didn't make the cut. It was reclassified as a dwarf planet, a new category that also includes other small icy bodies in the outer solar system. This decision sparked a heated debate in the scientific community and the public alike. Is Pluto a planet or not? The debate continues to this day, but one thing is clear. Regardless of how we classify it, Pluto is a fascinating world that has much to teach us about the outer reaches of our solar system. Despite its reclassification, Pluto continues to captivate us with its mystery and allure. As we delve deeper into the cosmos, who knows what secrets this distant and enigmatic world might reveal? In 2006, NASA launched a mission that would bring us closer to Pluto than ever before. The New Horizons mission was born out of a burning curiosity to explore the distant reaches of our solar system. Its primary objective: to fly by Pluto and capture the most detailed images of this icy dwarf planet that we've ever seen. The journey was no small feat. It took New Horizons nearly a decade to traverse the vast expanse of space between Earth and Pluto, but on that historic day in July 2015, all the waiting proved worthwhile. As New Horizons made its flyby, it provided humanity with its first up-close look at this far-flung world. And let me tell you, the images it sent back were nothing short of breathtaking. Before New Horizons, our best images of Pluto were little more than blurry pixels. But as the spacecraft approached, those pixels transformed into a complex and diverse landscape. Contrary to earlier expectations of a dull and monotonous world, Pluto's surface revealed a myriad of surprises. We saw mountains, valleys, and vast plains of frozen nitrogen and methane. It was as if Pluto was coming to life right before our eyes. But the revelations didn't stop there. Among the most surprising features discovered on Pluto is a vast heart-shaped region. This heart-shaped feature, named Tombaugh Regio after the planet's discoverer, consists of a smooth, icy plain bordered by rugged mountains and cliffs. Its origin remains a subject of scientific debate, with theories ranging from ancient impacts to tectonic activity. The New Horizons mission was a game-changer. It revolutionized our understanding of Pluto and shattered our preconceived notions of what a dwarf planet could be. New Horizons not only brought Pluto into focus, but also unveiled a world of unexpected diversity and complexity. One of the most striking features of Pluto is a vast heart-shaped region named Tombaugh Regio. This visually arresting feature, stretching across a large portion of Pluto's surface, is unlike anything else in our solar system. Tombaugh Regio is a vast plain of nitrogen ice, smooth and expansive, bordered by rugged mountains and cliffs. Its unique shape and composition have sparked intense scientific debate. The heart of Pluto, as it's often called, is a testament to the dwarf planet's surprising geologic activity. Theories about its origin range from ancient impacts to tectonic shifts. Some scientists propose that the heart's smooth surface could be the result of convective cells rising and falling in a sea of slow-moving nitrogen ice. Others suggest that Tombaugh Regio could be an impact basin, reshaped and smoothened over time by the flow of ices. Despite the uncertainties, one thing is clear. Tombaugh Regio is a dynamic and active geological feature. Its surface changes with Pluto's seasons as nitrogen and other gases sublimate in the sunlight, creating a weak atmosphere and then condense back onto the surface as frost as temperatures drop. Tombaugh Regio, a testament to Pluto's surprising geological activity, continues to intrigue scientists. Did you know that Pluto, a world much smaller than Earth, boasts towering mountains and a thin atmosphere? Yes, you heard that right. On this icy dwarf planet, far from the warmth of the sun, rises a mountainous terrain that rivals some of Earth's greatest peaks. These aren't your ordinary mountains, though. They're composed of water ice, hard as rock in Pluto's frigid temperatures, and they soar to dizzying heights of up to 11,000 feet. But how did these icy peaks form in such a distant and cold environment? The answer lies in the very nature of Pluto's crust. This outer layer, primarily composed of nitrogen, methane, and carbon monoxide ices, is incredibly dynamic. When subjected to heat from Pluto's interior or the sun's distant rays, these ices can sublimate, turning directly from solid to gas and causing the crust to shift and crack. The result? A dramatic landscape of towering peaks and deep valleys, a testament to the unexpected geological activity on this distant world. And what about Pluto's atmosphere? It's thin, very thin, but it's there. This tenuous envelope of gases, consisting mostly of nitrogen with smaller amounts of methane and carbon monoxide, plays a crucial role in shaping Pluto's surface. This atmosphere undergoes a fascinating cycle. As Pluto orbits the Sun, its distance varies, causing dramatic seasonal changes. When it's closer to the Sun, surface ices sublimate, thickening the atmosphere. But as Pluto moves further away, these gases condense and fall back to the surface as frost. This cycle of sublimation and condensation carves out an ever-changing landscape on Pluto's surface, creating a world that's far from static. It's a world that, despite its small size and distance from the Sun, is surprisingly dynamic and diverse. So, the next time you gaze up at our own mountains and take a deep breath of our thick atmosphere, spare a thought for tiny Pluto. Despite its small size, Pluto's topography and atmosphere reveal a world of unexpected complexity. Pluto's system of moons also holds its share of surprises. Orbiting the dwarf planet are 5 known moons, each with its own unique features and mysteries. The largest of these, Charon, is more than half the size of Pluto itself, making it the largest moon relative to its planet in our solar system. Charon's surface is marked by a massive canyon system, deeper and longer than the Grand Canyon, and a mysterious mountain in a moat. Then there's Styx, Nix, Kerberos, and Hydra, the 4 smaller moons that orbit Pluto. These moons are less spherical and more elongated, hinting at a tumultuous past. Their irregular shapes and compositions suggest a complex history of formation and evolution, far out in the distant reaches of the solar system. But perhaps one of the most intriguing mysteries of Pluto and its moons lies beneath their icy surfaces. Recent studies suggest that beneath the frozen crust of Pluto, and potentially some of its moons, may lie a layer of liquid water. This subsurface ocean, if confirmed, would be kept in a partially molten state by the heat generated from radioactive decay and tidal forces. The presence of these potential subsurface oceans could harbor the necessary ingredients for life as we know it. It raises tantalizing questions about the potential for habitability beyond Earth, even in the frigid realms of the outer solar system. As we continue to probe the mysteries of Pluto and its moons, we are reminded of the boundless wonders that await us in the cosmos. So what have we learned about Pluto, this distant and enigmatic world at the edge of our solar system? From its discovery in the early 20th century to the groundbreaking New Horizons mission, Pluto has continued to captivate and surprise us. This icy dwarf planet, once thought to be a dull and monotonous world, has revealed a stunningly diverse landscape marked by mountains, valleys, and vast plains of frozen nitrogen and methane. The heart-shaped region named Tombaugh Regio has sparked scientific debates about its origin, while towering mountains of water ice, some rivaling the Rockies, hint at intriguing geological processes. Despite its frigid temperatures and small size, Pluto boasts a thin atmosphere of nitrogen, methane, and carbon monoxide gases, playing a pivotal role in shaping its surface. The potential presence of subsurface oceans beneath Pluto's icy crust could mean that this distant world holds more secrets than we could have imagined. And let's not forget Pluto's system of moons, from the large Charon to the smaller Styx, Nix, Kerberos, and Hydra, each contributing to the complex history of this dwarf planet. Each new discovery about Pluto not only enhances our understanding of this dwarf planet, but also deepens our appreciation of the vast and varied cosmos